Your agent runs overnight on a massive codebase, and by morning, GPT 5.5 has lost the thread entirely, while GPT 5.6 is still coherent on page 100. GPT 5.5 is the cheaper, faster workhorse. GPT 5.6 is the long horizon specialist. Which one you actually need depends entirely on your workload, so let's get into it. Alright, test 1 is cost, and here's a real scenario. You're running a high-volume summarization pipeline, maybe 1 million input tokens a day, and at the wrong price point, that bill compounds fast and quietly wrecks your unit economics before you even notice. The per-token rate is the whole game for workloads like that. I pulled the official API pricing, and GPT 5.5 comes in at $1.25 per million input tokens, versus GPT 5.6's $2.00, so GPT 5.5 is about 37% cheaper on input and 17% cheaper on output at 10.00 versus $12.00. GPT 5.6 might use fewer tokens on a complex task and close that gap a little, but on raw sticker price, the numbers on screen are pretty clear. GPT 5.5 takes cost, and the gap on paper is pretty hard to argue with. $1.25 versus $2 on input and $10 versus $12 on output, so that's 1-0 in GPT 5.5's favor. The efficiency argument for GPT 5.6 is real, but it's a promise rather than a published number, so the cheaper model wins this round. I only caught that efficiency caveat because I've been running these models on real pipelines long enough to know when a spec sheet is doing marketing work. Drop a comment if the token bill has ever blindsided you on a project. Okay, test 2 is coding performance, and the number we're looking at is SWE Bench Verified, which is a real-world software engineering task suite. A low score here means more bugs slipping through, more back and forth with the model, and more time spent on review instead of shipping. Watch what happens on SWE Bench Verified. GPT 5.5 lands at 72.4%, and GPT 5.6 comes back at 78.9%, a 6.5-point gap. And on a benchmark this close to real engineering tasks, that's a meaningful jump in actual code quality. Both scores are vendor reported, so treat them as directional, but the direction is pretty clear from the numbers on screen. GPT 5.6 takes coding, and that ties us up at 1 apiece. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. I didn't expect a 6.5-point lead given how close these models are on price, but the SWE bench data says GPT 5.6 is genuinely the stronger coder right now. Test 3 is speed, and here's a concrete scenario you've probably felt. You're iterating on a prompt in a live session, and the model is slow enough that you lose your train of thought between responses. 24 extra tokens per second sounds small until you're literally waiting on every single turn, and that friction adds up across a full day of work. I looked at community measurements from artificial analysis, and GPT 5.5 clocks in at 142 tokens per second versus GPT 5.6's 118. So GPT 5.5 is roughly a fifth faster on output generation. These are community-reported figures rather than official ones, so treat them as directional. But that kind of speed edge on long generations is a real difference you'd feel in an interactive workflow. GPT 5.5 takes speed, and that puts GPT 5.5 ahead 2-1. I expected the newer model to close the gap here, but GPT 5.5 is still the faster output machine by a pretty clear margin. So GPT 5.5 is cheaper and faster, right? But context window and modality support are still ahead, and those two tests are where long horizon work either holds together or completely falls apart. If you've ever had a model drop context mid-task on a big code-based review, the next numbers are going to hit differently. Test 4 is context and output limits. You're doing a full code-based review, maybe 500,000 tokens of code, and your model just hits its wall and starts forgetting the earlier files, so you end up chunking it, reprompting, babysitting the whole thing. That's not a minor inconvenience. That's hours of overhead on a job that should have been automatic. I checked the official docs and GPT 5.5 tops out at a 400K context window with 128K max output, while GPT 5.6 comes in at 1M context and 256K output. That's 2.5 times more context and double the output, both from official vendor specs, and for any task that runs long, GPT 5.5 just physically can't hold the whole job in memory. GPT 5.6 takes context and output limits, and that ties the series back up at 2 each. Going from 400K to 1M context is the single biggest structural difference between these two models for anyone doing serious long horizon work, and it's really not close. Test 5 is deployment and modality. You're building a voice-driven workflow, maybe a hands-free coding assistant, or an audio transcription pipeline, and your model just doesn't accept audio input, so you're stuck bolting on a separate transcription step, which adds latency, cost, and one more thing that can break in production. I checked the official docs and GPT 5.6 accepts text, image, and audio input, while GPT 5.5 stops at text and image. On output, both models are text only, so that part's even. But the audio input gap is real, and if you're building anything voice-driven, GPT 5.5 just isn't in the conversation without extra infrastructure. To be fair, audio input only matters if your workflow actually needs it, and most pure text or coding workflows don't. But if you're not using audio today, the trend is pretty clearly toward multimodal pipelines, and GPT 5.6 is the one that's ready for that, without a rebuild. GPT 5.6 takes modality, and that's 3-2. GPT 5.6 wins the series. The audio input support pushed it over the line, and that's kind of the tiebreaker I didn't see coming when I started pulling these numbers together. So here's where GPT 5.5 is the clear pick. It's 37% cheaper on input tokens at $1.25 per million, and it generates output roughly a fifth faster at 142 tokens per second. If you're running high volume, routine tasks where context limits aren't a problem and cost is your hard constraint, GPT 5.5 is still a really solid option. And here's where GPT 5.6 runs away with it. It scores 78.9% on SWE Bench verified versus 72.4%. It has a 1-ARM token context window that's 2.5 times larger. It doubles the max output to 256K tokens, and it's the only one of the two that accepts audio input, which makes it the right call for any serious long horizon or multimodal workflow. If cost and raw speed are your whole world, GPT 5.5 at $1.25 per million input tokens is still a great pick. But if your tasks run long, your codebase is big, or you need audio in the loop, GPT 5.6 wins by a pretty wide margin. One thing the docs don't spell out, GPT 5.5's 400K context limit applies to the rolling context and multi-turn agent loops too. So a long-running agent will silently truncate earlier turns without any warning, and can start contradicting its own earlier outputs mid-task. And if you're now wondering how GPT 5.5 stacks up against a completely different architecture, I ran that same kind of deep comparison in Fable 5 versus GPT 5.5, which is already up. The results there are a lot less predictable than you'd expect, so go check that one out.